After this lesson, students will be able to use standard form to graph linear equations. Do now. Complete the table of values for the equation 3y minus 2x equals 12. Hint: substitute the x values and solve for y. Try the do now on your own, so pause the movie and resume when you're ready. So our x values are -6, -3, 0, 3, and 6. I can plug those into our equation. So 3y minus 2 times -6 equals 12. 3y plus 12 equals 12. Subtract 12 from both sides. 3y equals 0, which means that y equals 0. Now let's try with -3. 3y minus 2 times our x, which is -3, equals 12. 3y plus 6 equals 12. Subtract 6. 3y equals 6, so we divide by 3 to find that y equals 2. So when x is -3, y is equal to 2. Now I'm going to make some more space. So I'll erase this work. Now let's try it with 0. 3y minus 2 times 0 equals 12. 3y minus 0 equals 12, which means that 3y equals 12, or y equals 4. Now we'll substitute 3 in for x. 3y minus 2 times 3 equals 12. 3y minus 6 equals 12. Add 6 to both sides to get 3y equals 18. Divide by 3. Y equals 6. And finally, we'll plug in 6 for x. 3y minus 2 times 6 equals 12. 3y minus 12 equals 12. Add 12 to both sides. Divide by 3. And we get y equals 8. Now that we have these ordered pairs, we can plot them on the coordinate grid. -6, 0, -3, 2, 0, 4, 3, 6, and 6, 8. And then we can go ahead and connect these dots with a straight edge. And draw an arrow on both ends to show that this line goes on forever in both directions. Now for some follow-up questions. What is the value of y when x equals 0? Well, when x equals 0, y equals 4. What is the value of x when y equals 0? Well, when y equals 0, it's on the x-axis, which is at -6. Now, when x is 0 and y is 4, that's our y-intercept, because it's the point where the line crosses through the y-axis. The point at which y is 0 is called our x-intercept, because it's the point at which our line crosses through the x-axis. So now part 3 asks us to explain how you can make a graph of 3y minus 2x equals 12 without making a table. Well, we could find the x and the y-intercept by plugging in 0 for x and solving for y, and then plugging 0 in for y and solving for x. That would give us these 2 points, which we could then connect with a straight edge. So for example, the x-intercept is when y is 0, so 3 times 0 minus 2x equals 12. Negative 2x equals 12. Divide by negative 2, so x equals negative 6. This tells us that negative 6 comma 0 is a point on the line, which we could then graph right here. Now we can find our y-intercept by plugging in 0 for x and solving for y. So y equals 4, which means x is 0, y is 4. The point 0 comma 4 is a point on our line. And we could graph that and then connect with a straight edge, and we would get the same answer. Now, so far this chapter, we've talked about linear equations being in the slope-intercept form, y equals mx plus b. And when we learned to graph a linear equation in slope-intercept form, we started by plotting the y-intercept, which is the point on the y-axis, or b, and then from that point, we could use our slope, or rise over run, to plot the other points on the line and then connect with a straight edge. Linear equations can also be written in point-slope form or standard form. Today, we're going to focus on standard form, which is ax plus by equals c. And the graphing hint, which you just saw a preview of in the Do Now, is that you can easily find the x and y intercepts from standard form and then use those to efficiently graph the line. So as mentioned, the x-intercept is the x-coordinate of the point where a line crosses through the x-axis, and therefore the y-coordinate at that point is 0. So for example, find the x and y intercepts of 3x plus 4y equals 8. To find the x-intercept, we substitute 0 in for y and solve for x. So 3x plus 4 times 0 equals 8, which means 3x equals 8. X equals 8/3, or 2 2/3. So our x-intercept is 2 2/3, and as an ordered pair, we could write that as 2 2/3, comma 0, since this is our x-coordinate when the y-coordinate is 0, and that's what makes this point land on the x-axis. Now to find our y-intercept, we can substitute in 0 for x and solve for y. 3 times 0 plus 4y equals 8. 4y equals 8. Divide by 4, y equals 2. So when x is 0, y is 2. So our y-intercept is located at 0, 2. Now you try this on your own. Pause the movie and resume when you're ready. So to start, we'll find the x-intercept, which is the point where the y-coordinate is 0. Now when I substitute in 0 for y, 5 times 0 is 0, so I can even skip that step and just write that 2x equals 6. So x equals 3, which means that there is a point on the line at 3, 0. Now for our y-intercept, that's when the x is 0. 2 times 0 is 0, so I can just focus on the 5y equals 6, divide both sides by 5, and we get that y equals 1.2, or 1 1/5. So I know that 0, 1.2, or 1 1/5 is the y-intercept, a point on the line. Number 2. Find the x and y intercepts of 2x plus 3y equals 12. Well, our x-intercept is when the y is 0. 3 times 0 is 0, so I can ignore this part for now and write 2x equals 12, which means that x equals 6. So 6, 0 is a point on the line. It is the x-intercept. The y-intercept is the point at which the x-coordinate is 0. 2 times 0 is 0, so I'm left with 3y equals 12. And y equals 4, so we have the point 0, 4, which is a point on our line, and more specifically, it is the y-intercept, the point where the line crosses the y-axis. So now, graphing lines using intercepts. Graph 2x plus 3y equals 12 using intercepts. Well, this is the problem that we just did. So step 1 was to find the intercepts. We just did that, and we know that our x-intercept is 6, 0, and we know that our y-intercept is located at 0, 4. So now we can plot those intercepts on the graph, 1, 2, 3, 4, 5, 6, 0, and 0, 4. And step 3, we can draw a line through those points. Oop, that was not a straight edge, one moment. And then we draw arrows on both ends to show that the line goes on forever. Now note, you can isolate the y to transform standard form to slope-intercept form. So for example, we have 2x plus 3y equals 12. I could subtract 2x from both sides. This cancels out. We cannot combine unlike terms, so on the right we're left with negative 2x plus 12. And I did purposely put the negative 2x before the 12 because I'm trying to create slope-intercept form where y equals mx plus b. We do need to get the y by itself though in order for this to be considered slope-intercept form. And when we divide by 3, we actually have to divide everything by 3. So both of these terms on the right side of the equal sign. And we're left with negative 2/3 x plus 12 divided by 3, which is 4. Now if you were to take a look at our graph, if we were to plot this slope-intercept form, we would start with the y-intercept, 1, 2, 3, 4, and put a point. Then we would use our slope, negative 2/3, to find the other points, down 2 and over 1, 2, 3. And that is a point on this line. We could continue down 2 and over 3 and get to another point on the line. So you can see that this equation, 2x plus 3y equals 12, and this equation, y equals negative 2/3 x plus 4, are equivalent. They are both equations of the same line, but one is written in standard form and one is written in slope-intercept form. Now you try to graph this equation using the intercepts. So pause the movie and resume when you're ready. To find our x-intercept, we plug in 0 for y, which leaves us with 5x equals negative 10, or x equals negative 2. So negative 2, 0 is a point on the graph. Our y-intercept, we're plugging in 0 for x, so we're left with 2y equals negative 10. Divide by 2 to get y equals negative 5, and we have 0, negative 5 as a point on the graph. Now we go ahead and plot our two intercepts, negative 2, 0, and 0, negative 5. And we use a straight edge to connect those dots. Let's try that again. And then draw arrows on either end of the line. Now try this problem on your own. Pause the movie and resume when you're ready. We find the x-intercept first, where y is equal to 0, So that leaves us with 3x equals 15, and we get that x equals 5. Our y-intercept, we're plugging in 0 for x, which leaves us with 5y equals 15, and we get y equals 3. So now we plot those 2 points, 5, 0, and 0, 3, and use a straight edge and draw arrows on both ends. Now let's talk about graphing horizontal and vertical lines. In our first example, we are asked to graph y equals -3. Now notice how this does not look like slope-intercept form, nor does it look like standard form. However, you can rewrite it in one of these forms, which may help you to think through how to graph it. For example, there are no x's in this equation, so the coefficient in front of the x would be 0. In front of our y, we have our invisible coefficient of 1, so we have 0x plus 1y equals -3. Now, if we were to try to use the strategy we've been using, which is finding the x and the y intercepts, we're going to stumble upon a problem. Let's try it. So we'll start by finding our x-intercept, which is when we substitute 0 in for y. Well, that leaves us with 0x equals -3. If we're trying to divide by 0, that gives us an undefined answer, since you're not allowed to divide by 0 or have 0 in the denominator. So that's problematic. Let's see what happens when we try to find the y-intercept. Plug in 0 for x, and you're left with 1y equals -3, which is just y equals -3. So we know that there is going to be a y-intercept at -3. But when we got an undefined answer for our x-intercept, that tells us that there is no x-intercept. The only way for this line to never cross the x-axis is for the line to be parallel to the x-axis. That way it will never cross. So the equation y equals -3 is actually a horizontal line that crosses the y-axis at -3. Another way that you can think about this is that for all values of x, y is always going to be -3. So if I were to try to create a table of values, no matter what points I pick for my x, my y is always going to be -3. When I plot these points, for example, -3, -3, that gives me this point. 0, -3 is this point, and 3, -3 is this point. And that can also help to remind you that this is a horizontal line. Now let's try example 2. Graph x equals 2. Well, just like before, we can start by trying to change this to standard form. 1x plus 0y, since there is no y, equals 2. Now if I try to find the x-intercept, I'm plugging in 0 for y, which leaves us with 1x equals 2, or x equals 2. So we know that 2, 0 is a point on our line. To find our y-intercept, we're plugging in 0 for x, which leaves us with 0y equals 2. And again, we end up with a problem that we cannot divide by 0. This shows that there is no y-intercept. So I plot the x-intercept, 2, 0, and knowing that there is no y-intercept, I know that our line can never cross the y-axis, which means that our line must be parallel to the y-axis, which means that this line is a vertical line that crosses through the x-axis at 2. Just like before, you can also think about creating a table of values if you get stuck. So pick points for x. Well, x always has to be 2 because our equation is x equals 2, regardless of what y is, since we don't see a y here. So again, we could do something like -3, 0, and 3. 2 comma -3 is this point, 2 comma 0 is this point, and 2, 3 is this point. So that may also help you to see that it's a visual or a vertical line. Now you try to graph each of these 4 equations, so pause the movie and resume when you're ready. Number 1, y equals 5. Well, just like in our example previous, whenever we have y equals a number and there is no x variable in our equation, this means that regardless of the x coordinate, y will always be 5. 1, 2, 3, 4, 5. And therefore, this is going to be a horizontal line. Y equals 0, which means it'll also be a horizontal line since it's y equals something, so regardless of what the x coordinate is, y will always be equal to 0. So this is actually on our x-axis. Now for x equals -4. Well, for x equals -4, we're going to have a vertical line that crosses through the x-axis at -4. And finally, x equals 0, which is a vertical line with an x-intercept of 0. Now let's talk about transforming equations from slope-intercept form into standard form. Now the key here is to know that standard form does not have fractions. So not only do we need to rearrange our variables so that we get it in the form ax plus by equals c, but we also need to get rid of any of the denominators. The other thing that is a little bit of a mathematical debate amongst various mathematicians is whether or not a, the coefficient in front of x, has to be a positive number. Since some people say that it does have to be positive and others say that it does not matter, we're going to make it positive to appease everybody. So, step 1, we have our equation in slope-intercept form, and we're going to multiply every single term by the least common denominator, which in this case is 4. So, 4 times y is 4y. 3/4 x times 4 leaves us with 3x, which you can do on the side if you need. So 3/4 times 4, which is 4 over 1, cross reduce, and you're left with 3 over 1, or 3x, plus 2 times 4, which is 8. So step 1, we multiplied every term by the least common denominator, which now got rid of our fractions. Next, we need to rearrange this to be in the form ax plus by equals c. So we can subtract 3x from both sides, and these are not like terms, so we're left with -3x plus 4y equals 8. Now we have the form ax plus by equals c with no fractions, but as I mentioned, our a is currently negative, And some people say that that is not an acceptable thing for standard form. So in order to get rid of our negative, we can multiply every single term by -1. So we're left with 3x minus 4y equals -8. Now the reason we're allowed to do that is that this actually didn't change our question. We multiplied both sides by -1. And as long as we do the same thing to both sides of the equal sign, we're okay. So we multiply every term by -1 to get our final answer of 3x minus 4y equals -8. Now you try these two questions on your own, so pause the movie and resume when you're ready. So first of all, our equation is in slope-intercept form. And when you see a negative that's lined up with the fraction bar, you can choose whether or not you want to move it to the numerator or the denominator, but just one space. I moved mine into the numerator so that I can see more clearly and not forget about it. So now, our first step, multiply every term by the least common denominator in order to get rid of the fractions. Our least common denominator is 5, so 5y equals -2/5 times 5 is -2x plus 1 times 5, or 5. Now I rearrange it to the form ax plus by equals c, so we add 2x to both sides, and we're left with 2x plus 5y equals 5. Our a is positive, so this is our final answer. Number 2. Y equals 2/3 x plus 6. Our least common denominator is 3, so 3y equals 2x plus 18. Subtract 2x from both sides, and we're left with -2x plus 3y equals 18. Our a is currently negative, so I'm going to multiply every term by -1 to get 2x minus 3y equals -18. Finally, let's look at some real-world examples of when you would write an equation in standard form. Write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bicycle and swim laps in order to burn 300 calories. Well, our table shows the activity by a 150-pound person. So now we don't need to worry about this number 150 because that's what all of these are showing. So we're looking at bicycling, which means that that person burns 10 calories per minute, and we're looking at swimming laps, where the person will burn 12 calories per minute. So in order to burn 300 calories, we would say 10x plus 12y equals 300. 10 times the number of minutes that that person bicycles plus 12 times the number of minutes that the person swims laps should equal the 300 total calories burned. Now you try number 2 on your own. Pause the movie and resume when you're ready. Write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bowl and walk to burn 250 calories. Well, bowling burns 4 calories per minute, and walking burns 5 calories per minute. So our answer is 4x plus 5y equals 250.